So today we gather here to figure out how to implement a t-test. T-test, it's kind of a statistic data. And before I start that, I want to tell you guys about two different statistic data that we have. We have descriptive statistics, which talks about your median, your mean, averages, absolute division, and variances. These are the data that just gives you the information. You can't use it beyond the information that's provided for you. The other one is inferential statistics. These are statistics data you can kind of predict or use it to infer other information other than the data itself. One of those is the t-test that we're going to talk about today. T-test, basically what it does is a test to determine the two means of your data, the average of the two data. Are they the difference between them? Are they significant and are they reliable? Okay? That's what the t-test will provide for you. What you are going to do right now is put these numbers in your Excel sheet. Click on cell next to or anywhere on your Excel format. Put in equals t-test and open up a parentheses. As you notice, when you open it up, these four items pop up in your bracket, correct? It says array 1 and array 2. Do me a favor, scroll all the numbers in your first column, put in a colon, go to array 2, do the same thing with the same numbers, with the next numbers actually. Put your colon in. Now the next thing that it's going to ask you to do is the tails. What basically the tails are, it refers to the tails on a bell curve. There are two different tails that you have. We have one tail test that is used if we want to see the statistical significance at one end of our bell curve. We want to see what happens at this end, or we want to see what happens at this end. That's a one tail. And what we're doing today, you're going to use a one tail. So in there, just put in 1. The other choice that you have is a two tail test. This is used if you want to see what happens at both ends of our bell curve. We don't want to do that today. We just want to look at this. So we're going to put in 1 for this number. The last section of it is the type. This is where we're going to figure out the t-test samples that we have. For our sample, we have the same students taking a test at 2 different times. So that gets us to the first type, which is the paired sample where 2 data sets are the same from the same population. That's what we're utilizing today. The other 2 are independent unpaired samples. It's when you have 2 samples, but they are from different populations. And for them, you have 2 choices. The choices are if your data samples, their variance are different, or if their variances are equal. If they're equal, you use type 2. If they are the same, you use type 3. What's the variance? It's basically a statistical value used to designate how far apart your numbers in your data groups are. Nothing that you have to worry about. I just wanted to let you know what the variance is. Now, what you're going to do, you have 1, 1, all the numbers in, close your bracket, and press enter. You'll see a number there? Yes? Okay. Oh, so let's see what you do here. T-test, open up a bracket. Put your numbers in. computers are a little messed up. Is everybody else having a difficult time, or? One?
I got the number.
Yeah, we're gonna talk about what that number means in a second. Okay, so most of you receive the number. What that number utilizes, interpreting the data. The results from a t-test tells you three things. It proves or disproves a null hypothesis, and it disproves or proves an alternate hypothesis. If this fails, obviously if this fails, then it proves the other one to be an accurate one. And it also indicates the mean difference between your data. Is the mean difference a significant difference or not? Now, the number that you received, if it's below 5% or below 0.05, that means whatever you were trying to prove here as your null hypothesis, it's been proven. If it's above this, that means what you have is not an appropriate number. And it tells you that the data that you have, it's not by chance. For example, let's say the two tests that you have, the numbers that you put in, as I said, the test in, I think I have it in September and in January. These two numbers are the two tests of ACT during first period, during the first exam, and your test results from the second exam. Basically, the numbers that you have, I think it's 0.0286, is that what you have? It tells you whatever you implemented in your class has had a significant, it has made a significant difference in the test scores of your children. So it's basically whatever program you have implemented in that class, it's working. And that's basically what a t-test does. You set the two data, and it tells you what you're doing in your class. Is it working or it's not working? Okay? And that ends